Hello everyone. This time I want to start from the end. I will start manipulating a drum patch and then explain how I built that. In particular, I will demonstrate how I am applying three different LFOs to the three different instruments that are loaded into the patch. So I have a kick drum and a snare drum and hi-hats loaded into my Unirack instance, and I have LFOs here that are loaded as rack modules, and you can see I have LFOs for hi-hats, for kick, for snare, and I will demonstrate how to affect parameters of the different instruments by using the patchbays down here that will allow me to select different parameters of each instrument and manipulate the parameter using the LFO. And the LFOs have different waveforms. So I will demonstrate how changing the shape of the LFO right here will affect the parameter of the instrument. And these LFOs have a shape that has a continuous interpolation between sine wave, triangle, and sawtooth and square. So it's a continuous value that I can use to change the shape of the LFO. I can change the frequency. The amplitude will stay at 1 because I can actually map the range of the LFO using the parameter, using the patchbay range, the lower limit and the upper limit. So what I want to do is demonstrate this flexible patchbay system where I have one control data module here loaded, and then I have my instrument loaded, and with the patchbay PD, I can select the different parameters of the instrument and start playing with that. I am using for this patch a sequencer. It's a topograph sequencer, which is an emulation of the same named sequencer in VCV Rack, the famous sequencer by Valley, which is in itself a emulation of the Mutable Instruments grids sequencer. And I'm using an Euclidean pattern, but there are three other kinds of patterns. You can look up the topograph sequencer. It's a pretty much perfect emulation of that in Unirack. So I won't go into all of the modules, but I will demonstrate after the sound demonstration how to build up this patch. And so let's get to it. Now I'm operating on the frequency of the kick as a triangle, sawtooth, and this is going to be a square. I can decrease the frequency. So opening up the other ones. LFO. The pitch of the snare. And I can of course change the parameter that I'm changing by going to FPS patchbays. It's for the hats, it's for the snare. Instead of pitch, let's change the noise. And let's do one. Snare. Let's change the etc, etc. You can see that the precision of the sequencer is pretty good. It's pretty steady. Changing the density of the pattern for the kick. Etc, etc. So this is an example of how to patch a drum pattern in Unirack. You can see it's pretty flexible. I can do things on the fly while playing the patch, and all of the values will persist whenever I hit stop, because these are all assets. These are all scriptable objects that exist independent on the don't destroy onload method. So they don't depend on, they're not like mono behavior scripts. They exist, they're persistent across the scenes. They exist as assets in the whole game. Now let's see how to build a patch from scratch. So here I have a new scene called drums, and I can start creating new objects, new modules for the drum track. So in my instrument menu in the module manager, I can select a kick, and it will create it as an asset called drums, which is the name of the scene, underscore the type of instrument, which is a kick drum. So I create that, and I will leave the polyphony to 1, because each one of these instruments is going to be monophonic. Hats, and now I have all of my instruments, and then I can start creating my blocks. I can create a filter for this, let's say, and for all of my effects, the effects are going to process all of the drums. So for this, this drum patch, I'm going to have 3 instruments. So I can set the polyphony of the filter to 3. I can add a feedback module, also delay feedback, and set the polyphony to 3. Then I'm going to have my reverb for the auxiliary, and that's going to be polyphony 1, because it's an auxiliary. process, and it will process things with sense, so I don't need polyphony there. What else? I can have a velocity quantizer. So for this one, I don't need an ADSR because drum instruments have a envelope built in, so I can just have a velocity controller for them, and that's that. And that also needs to be polyphony 3, and it only has one controller, which is the velocity. And in the Unirack instance, I can load my instruments 1, 2, and 3. It's going to be drums kick first, then drums snare, and then drums hats. For PD blocks, I can load my drums filter, then my drums feedback, delay feedback, and then my velocity, drums velocity, add sense to each channel. So in channel control, I add channel control, and that's going to be polyphony 3 again. I add the channel control, and that's it for my patch. Then I will need a sequencer. So I go into rack modules, load a sequencer. And for sequencer, let's use the topograph. So I can load that into my sequencer topograph. One thing I need to add is timer, and add the global timer script, set the frequency to 1. And you can see how each one of these instruments has different parameters. Okay, now if I hit play, the patch will be generated. You can see that each instrument has a different name now, and they do have all the same filtering and delay blocks. And I have just a velocity quantizer for volume, and then my mixer channel strip. And I need to load my controller for the velocity, which is my topograph, and I need to assign it to my velocity for drums. I will sync the polyphony to 3, and I will only have one, which is I will send the level of the topograph to the gain of the velocity, and I can map that in with a range sliders. Anything can be controlled with patchbays. I can change the pan. Actually, let me try to do that. I will create a new rack module, a single LFO for just controlling the panning of the different objects. Patch pan, create that, and then load my single LFO pan for controller. Load the channel control. So sync the polyphony. One parameter, the output is going to be mapped to the panning. So LFO pan, and then I need to load the patchbays. If I want to reduce the panning influence, this is almost no panning. So let's start increasing the panning of the drum set, the kick drum. So I'm just increasing the range of the panning that it's been patched, of the LFO that is being patched to the panning. That's the delay time that I'm patching. what if I now it's operating on the feedback. I hope this is helpful and interesting, and please let me know in your comments if you have any questions. Feel free to reach out to me if you're interested in knowing more about this project. And until the next time, take care.